Alright, hello guys. In this video, we're going to go over how to do first order homogeneous differential equations. And the first step, as said in the instructional, is just recognizing if it's a homogeneous differential equation or not. And we are able to do this by looking at every x and y term and analyzing if they all have the same exponent. Then we apply the properties of homogeneous differential equations. So notice here we have an exponent of 2. Notice here we have an exponent of 2. And notice here we have an exponent of 1 and 1, which adds up to be 2. So since they all have the same power, we go ahead and apply homogeneous differential equations. And they're a little bit different, but they're not too strange. So one thing we do for homogeneous differential equations is we apply the substitution v. So basically the way the v substitution works is that our y is equal to v times x. And then when we take the derivative of y, our dy is equal to v dx plus x dv. And I did that using the product rule, which I won't go over how to do in this video, but I do have a video on that as well. And basically we want to be able to just apply these v substitutions into our current function. So the idea is now to just plug and substitute the v variables where we see y. So x squared minus our y vx squared, and then all this in parentheses, dx plus 2x, and then our y substitution vx, and then our dy substitution v dx plus x dv. All this would be equal to 0. So the next step would be to just simplify this as much as we can. And we're trying to isolate v with dv and x. So we do this by just applying a lot of algebra. So x squared minus v squared x squared dx plus 2x squared v parentheses v dx plus x dv equals 0. And now the next step would be to just apply further distribution. So x squared minus v squared x squared dx plus 2x squared v squared dx, because I'm distributing it with this term, and now distributing it with the next term, we would do plus 2x cubed v dv is equal to 0. So all I did was just distribute this. I factored it into here, and I factored it into here. So now with that, we're going to go ahead and just keep simplifying. We're going to keep simplifying a little bit further. So we're going to combine the x terms and the v terms. So x squared minus v squared x squared plus 2x squared v squared dx is equal to, since we're going to bring this over the equal sign, we're going to change the sign, 2x cubed v dv. And now the next step would be to notice that we can factor out an x squared, because we have an x squared on every single term. So we're going to go ahead and factor it out. And what we're left with is, we're left with 1 minus v squared plus 2v squared to the times dx is equal to negative 2v dv. And now all we have to simply do is isolate x with dx and isolate v with dv. So we're going to go ahead and do that in the next page. So 1 minus v squared plus 2v squared to the dx is equal to negative 2v dv x times x. There's an x in here. Times negative 2x v dv. So the next step would be to just isolate the x and the v. So we simply do that by just applying simple algebra. So dx divided by x is equal to negative 2v divided by 1, simplifying these terms, minus v squared plus 2v squared is equal to 1 minus 1 plus v squared times dv. And now that we've isolated both terms, now we just apply separable differential equations, noticing that we have one side with respect to x and the other side with respect to v. So the next step would be to integrate both sides. So that's what we're going to go ahead and do. We're going to take the integral of dx divided by x is equal to pulling the constant out in front, the integral of v over 1 plus v squared times dv. And the next step would be to just integrate. The natural log of x plus c is equal to, in this case we have to apply a u substitution because we notice that the exponent on the bottom is greater by exactly 1. So we're going to go ahead and apply u substitution. So u substitution, our u is equal to 1 plus v squared. Our du is equal to 2v dv. And our dv is equal to du divided by 2v. So all we simply do now is just substitute it back into the integral. So negative 2 integral sign, see if I have room, v over u du over 2v. And we cancel out the v's. We cancel out the 2 on the denominator with the 2 outside of the integral sign because they will cancel out when we pull it out. And we're left with the integral of negative sign du over u. And integrating that, we get negative natural log of u, which is also equal to, substituting the v variables back in, we get 1 plus v squared. But note that v was also a substitution, so we have to do a further substitution. So I'm just going to do it right here, down at the bottom. The natural log of x plus c is equal to the negative natural log of 1 plus v. Y was equal to yx, which means v is equal to y over x. So plugging in v, where we see, plugging in our y term back in, we get y over x squared. And that's how we do homogeneous differential equations. Thank you. Hello guys, in this example, we're going to go over how to do homogeneous differential equations of first order. And the idea behind it is basically looking at the x and y variables on this function. We notice that x is to the power of 1, y is to the power of 1, and x is also to the power of 1. So Noting that they all have the same power, we can apply the properties of homogeneous differential equations in order to solve this differential equation. So the idea is to turn this into a separable differential equation and then solve it like a separable differential equation. And if you don't know how to do that, I have a video on separable differential equations in this playlist. And so without further ado, for homogeneous differential equations, it's good to apply a v substitution because it makes the problem a lot easier. So that's what we're going to go ahead and do. We're going to go ahead and apply a v substitution. So our y is equal to vx, and the derivative of this dy, applying the product rule, would be equal to v dx plus x dv. So in doing so, now that we have our substitutions, all we simply do is substitute them back into the formula. So x minus our y, which is vx, times dx, plus x times dy. What's our dy? We substitute v dx plus x dv. And all this is equal to 0. So we're going to go ahead and just make room down here to keep solving this problem. So x minus vx to dx plus x v dx plus x dv is equal to 0. So what we're going to do now is we're going to simplify and distribute just using basic algebra. So x minus vx dx plus xv dx plus x squared dv is equal to 0. And all I did there was just distribute the x into both of these terms. So now what we do next is we combine all the x, all the dx terms, and all the dv terms. So right here we have x minus vx, and then we have a dx term over here, so plus vx multiplied by dx plus x squared dv is equal to 0. So the next step would be to cancel out these, simplify further, and let's go ahead and bring this dv term to the opposite side. So we're left with x dx is equal to negative x squared dv. So now what we do next is we bring all the x terms to the x side, right? So x over x squared times dx is equal to negative dv. Now you have the form of a separable differential equation. So we're going to go ahead and just integrate both sides. Integrating both sides, notice how this is just simplified to 1 over x. So the integral of this would simply be the natural log of x plus c, because it's the integral of 1 over x. The integral of 1 over x is natural log of x plus c. And the integral of dv would just be v, which is equal to negative v. But now don't forget to do this last step, which some people do tend to forget. Remember, we did perform a substitution right here. So our v is actually equal to y over x. So all you have to simply do is just substitute that term back in. So the natural log of x plus c is equal to negative v, which is equal to negative y over x. And that would be all. That's how you perform any homogeneous differential equation. So the idea is, look at the powers of the x and y terms, and if they do have the same power, if all the terms have the same power, then go ahead and perform the properties of homogeneous differential equations. Identify your v variable substitution, so your y will normally equal vx. Your dy will normally equal its derivative, which is just taking the product rule, which is v times dx plus x times dv. After that, perform a bunch of algebra to simplify it and turn it into separable differential equations. And once you do that, just integrate both sides like you would for a separable differential equation, and that's it. Thank you guys. Hope it was helpful.